Welcome to Section 2, Introduction to Fraud Detection. This is Lecture 5, exploring the credit card fraud dataset. So I've provided a link to the web page on Kaggle that contains the credit card fraud dataset that the authors of this machine learning research group have luckily provided. It's in the public domain, so we can just grab it off of Kaggle. If you don't know what Kaggle is, it's a website that hosts machine learning competitions. There are a lot of data sets. There's a lot of notebooks, interactive notebooks that contain solutions to problems. Organizations and groups also holds machine learning competitions, and then people provide solutions. They submit. There can be prize money to be won for certain competitions. So yeah, it's a great place to look at really good machine learning models that people develop, to find access to really good data sets, and it's just a nice central repository for all these things that you might want to use within your machine learning journey. Okay, so we are going to now use pandas within Python to interrogate and understand what the data actually looks like. So we're going to be using pandas, and I'm going to use the pandas.readCSV method to read in the CSV file, assuming that the directory is in the same folder as my notebook. I'm just going to assign that to a variable called df for data frame. And then once that's done, if I want to see what the data frame looks like, I can just print the head, which will just give me a snapshot of the top 5 rows as well as all of the columns in the data frame. And if I want to do some more high-level descriptive statistics, I can use dataframe.describe, and that'll actually tell me what the count, the mean, standard deviation, the min, the max, that kind of thing, for each of the numeric columns within the data frame. All of them are numerical, so they all do show up. But if you've got some categorical or text-based columns and things like that, it won't include it in the output of the .describe method. Okay, so we see that there are 31 columns within this data frame. There are 284,000 records or rows, and the features, they are expressed at the transaction level, right? So they're not aggregated at the user level, rather at the transaction level. But a single user might have multiple transactions. These could just be credit card swipes, for example. And they include features such as the transaction amount, so the amount that was swiped for, the time of the transaction, and a number of features or columns called V1 through V28. Okay, and we know, because there are research papers associated with this data set, the authors have claimed that the features have been derived from a process called principal component analysis, which is effectively an approach for reducing the dimensionality of the data. So what that means is the data set was likely a lot wider, so that the size of the feature space was a lot broader. There might have been 100 features, for example. They then applied PCA to reduce that number down to the 28 of them, which is great. The only problem is that it removes the interpretability aspect. It makes it difficult to understand exactly what these features kind of represent. We can train a model and then post hoc understand, well, which of these contributed to the modeling decision, which ones contributed most to the detection of fraudulent records. But at the end of the day, we don't actually know what this V4 means or what this V3 means, for example. All right. But they obviously still are proven to be informative features, so they will help us to detect instances of fraud within this data set.